Hello, aspiring student programmers. Today we're going to embark on an exciting journey through the world of asynchronous programming in JavaScript. As you may know, JavaScript is a powerful language for web development, enabling us to create dynamic, interactive websites. One of its core features is the ability to perform tasks asynchronously, meaning it can process things like API calls, file operations, or timers without blocking the main thread. This is crucial for building fast and responsive applications. In our exploration, we'll delve into 4 key concepts that form the backbone of asynchronous programming in JavaScript: callbacks, promises, async await, and promiseAll. Each of these concepts allows us to handle asynchronous operations in different but equally powerful ways. Callbacks are fundamental to JavaScript, enabling us to execute a piece of code after an asynchronous task completes. Promises provide a more powerful and flexible way to handle asynchronous operations, allowing us to chain operations and handle errors more gracefully. Async await syntax makes our asynchronous code look and behave a bit more like synchronous code, making it easier to read and understand. promiseAll is a fantastic tool for managing multiple promises concurrently, ensuring that we can efficiently handle situations where multiple asynchronous tasks need to complete before proceeding. Understanding these concepts will not only improve your coding skills, but also open up a world of possibilities for creating efficient, effective, and elegant JavaScript code. Whether you're building simple scripts or complex web applications, mastering these patterns will make your code more robust, readable, and reliable. Now let's dive into the code and see these concepts in action. Callbacks, the foundation of asynchrony. The callback example begins with a function example callback that takes a callback function as its parameter. This demonstrates how asynchronous operations were traditionally handled in JavaScript. Inside, setTimeout simulates an asynchronous operation, such as fetching data from a server, which after completion calls the provided callback function with either an error or a result. How it works: the setTimeout function is non-blocking, allowing JavaScript to continue running other code while waiting for the timeout to complete. Once it does, the callback function is invoked with 2 arguments: null for errors, since there's no error, and callback result as the successful result. This pattern, where the first parameter is reserved for an error and the second for a successful result, is a convention in Node.js and helps in differentiating between successful and failed asynchronous operations. Desired outcome. The main goal here is to understand how callbacks provide a way to continue code execution after an asynchronous task completes without blocking the main thread, thus maintaining the application's responsiveness. A leap forward. Moving to the example promise function, we encounter the promise AP1, which represents a significant improvement over callbacks for handling asynchronous operations. A promise in JavaScript is an object that may produce a single value sometime in the future, either a resolved value or a reason that it's not resolved. For example, a network error occurred. How it works: the function returns a new promise object, taking 2 functions as parameters: resolve and reject. Inside the promise, setTimeout simulates an asynchronous task. Upon successful completion, resolve is called with the result, while reject is called if an error occurs. This structure simplifies error handling and chaining asynchronous operations compared to callbacks. Desired outcome. The introduction of promises aims to address callback hell, the situation where callbacks are nested within callbacks, leading to complex and hard-to-read code. Promises provide a cleaner and more manageable way to handle asynchronous operations, allowing developers to chain operations and handle all errors in a single catch block. Syntactic sugar for promises. The example async await function showcases the async await syntax, which builds on promises, providing a more synchronous-looking way to handle asynchronous code. The async keyword before a function declaration makes it return a promise, and the await keyword can be used inside to pause the function's execution until the promise resolves. How it works: inside example async await, we await the resolution of example promise. This tells JavaScript to wait until the promise settles, and then to proceed with the function, using the resolved value. If the promise rejects, the error is caught in the catch block, demonstrating effective error handling. Desired outcome. Async await makes the asynchronous code easier to read and write. By avoiding the explicit chaining of promises and reducing the boilerplate around promises, async await allows for clearer syntax and better error handling with try-catch blocks. Managing multiple promises. Finally, example promiseAll demonstrates the use of promiseAll, a method that takes an iterable of promises and returns a single promise that resolves when all of the input promises have resolved or rejects if any of the input promises reject. How it works: we create an array of promises, simulating multiple asynchronous operations that can run concurrently. promiseAll waits for all of them to complete, collecting their results into an array, which is then available in the then block. If any promise fails, promiseAll immediately rejects, and the error is handled in the .catch block. Desired outcome. The purpose of promiseAll is to synchronize multiple asynchronous tasks, making it essential for scenarios where the completion of multiple operations is required before proceeding. It optimizes concurrency, ensuring that asynchronous tasks are completed in the fastest possible way without waiting for each task to complete sequentially. Evolution from callbacks to promises. Promises were developed as a solution to the shortcomings of callbacks, primarily to address callback hell, improve error handling, and make asynchronous code more readable and maintainable. With promises, developers can chain asynchronous operations in a cleaner way, handle all errors centrally, and write code that is closer to synchronous in appearance, enhancing readability and reliability. The async await syntax further simplifies working with promises, allowing asynchronous code to be written with a synchronous flow, making it even more accessible to developers. As we wrap up our journey through the asynchronous landscape of JavaScript, it's crucial to understand how these concepts we've explored, callbacks, promises, async await, and promiseAll, play integral roles in the larger context of web development. In building web applications, the need for efficient, readable, and maintainable code cannot be overstated. The evolution from callbacks to promises and async await patterns marks a significant leap towards achieving these goals. Imagine you're developing a web application that requires data from multiple sources, such as user information from a database, third-party API data for weather forecasts, and real-time stock market updates. In such a scenario, understanding and applying these asynchronous patterns become not just useful, but essential. The ability to perform these operations concurrently without blocking the main thread ensures your application remains responsive, providing a seamless experience to your users. The concept of callbacks laid the foundation for asynchronous JavaScript, but as applications grew more complex, the limitations became apparent. Promises emerged as a powerful abstraction, offering a more structured approach to handle asynchronous operations, reducing the risks of callback hell and improving code readability. This transition to promises represents a shift towards more predictable and manageable code, making error handling more straightforward with the use of then for success scenarios and .catch for errors. The introduction of async await further refined the way we write asynchronous code, allowing us to write promises in a style that looks synchronous, making our code even cleaner and easier to understand. This syntactic sugar on top of promises has significantly enhanced code readability and has made asynchronous error handling as simple as synchronous code using try-catch blocks. Moreover, the use of promiseAll demonstrates an efficient way to handle multiple promises, enabling your application to wait for several asynchronous operations to complete before proceeding with the next steps. This not only improves efficiency, but also opens up new possibilities for parallel data fetching and processing, crucial for building high-performance web applications. In the grand scheme of web development, these patterns offer extensibility and reusability. Functions built around promises or async await can easily be reused across different parts of an application or even across projects, reducing development time and increasing productivity. As JavaScript technologies continue to evolve, staying adept with these asynchronous patterns will ensure you can leverage the full potential of the language to build robust, efficient, and scalable web applications. Thanks for watching, everyone, and don't worry if you missed anything. We've added a link to the source code in the description. If you found this video to be helpful, please like and subscribe for more of the same. Thanks again. And remember, we're always learning, so keep coding, keep exploring, and keep building amazing web applications.